Hello, this is a follow-up of one of my last videos regarding the DM858 of Rigol. This is my third meter of Rigol. The first two I have bought at in 2024 and both were returned by me because of the hardware failures were regarding the DC voltage topics, and I want to look to it to the newest version. The newest version has the hardware version 102 and also newer software. And I want to retest the problems I had with my previous Rigol multimeter and see how this new meter is behaving. One of the problems was that at the moment that you were in the manual mode of 100 millivolt or 1 volt, and if you exceed the the voltage, you get an overload situation, which is normal. But what was not normal was that if you are going above 1 volt, let's say 5 volt or whatever, you get not an overload condition anymore, but some numbers as it was that you are measuring millivolts or something like that. That I have shown in one of my previous videos. You can see that in my playlist. But I have set up now here the Rigol, which is connected to the current measuring meter of Unity. It is in I put that in series, and it is connected to the power supply. You can now see it is 1 volt. Okay, 1 volt, and the current it is drawing is 100 microamp. 100 microamp means that there is a relation of, let's say, 10 mega ohm, which is okay, which is fine, and that is that is how it should be. That was also the case, by the way, with my old meter, so no problem there. But what happens when I increase it? Now, first, if I increase it, the voltage, you will get automatically an overload, and you see here there's an overload. It is even, and this is new, I think. I see a plus sign now, plus overload. I come to that in a minute about that subject. But okay, if I go, let's say I put now a higher voltage, you can see that at the moment that the voltage is now 10 times the maximum. You see that the current drawing is not really a huge number. It is still 7 microamp, and that means that it is away in its limits. It is more than the 10 mega ohm now, but okay, that's not a problem. The same happens if you are going, let's say, in the 100 millivolt. You will have also the same thing. If I change the polarity, you can also see that that's also okay. And now here you see overload with the minus sign. Nothing wrong about that at the moment. If we go to 10 volt, then you get this. That's fine. Another test I did to test the Autorange was my capacitor test. I charged the capacitor, and then I was measuring the voltage via the Rigol, and when I was doing that and I was every time tipping it, then it was discharged via the multimeter very fast, which indicates that the Autorange was not working properly. So I will redo the same test what I have done 1.5 years ago. Before I do that, I put the meter in auto, of course. I have here the oscilloscope. The blue trace is connected to my power supply, so if I switch it on, then you can see that it is here 10 volt. There the blue line is also 10 volt, and the yellow trace will be the capacitor. So I have to charge first the capacitor, and then I will do the test. So first I will charge the capacitor. So now you see that the blue trace and the yellow trace are on the scope, yeah, the same level. I will remove my power supply, and then you see normally drop. The capacitor is discharging via yeah, the oscilloscope, which has an 1 mech resistance, so it is slowly drawing some current. But okay, this is normal, nothing special. But in the old situation, when I was testing this with the multimeter, and it is now in Autorange, if I measure it, you see 8.7 volt, and if I do this, you hear the relay clicking, but if you watch on the oscilloscope, there is no drop seen. So that means that the meter looks like it's working properly. Yeah, that's very good. That's very good. I mean, this is how it should work. Yeah. Okay. Now then, some positive news about the signed overload addition in this probably newest hardware, in the 102 at least. I have connected my generator, which is generating 100 millihertz signal, and I have used the trend function of the multimeter, and you can have a trend of maximum 60 seconds. There is only one time scale that you can have. There is no, unfortunately, there is no possibility to get it for 5 minutes or 1 hour or whatever or longer. That's really not good. I hope that an upcoming software release will fix that, but nevertheless, at this moment we see the sine wave correctly displayed. You can also see it on the oscilloscope, by the way, but the idea was what is going on at the moment, that you are going over the 1 volt limit, and then the signed signal is becoming important. So I have now plus minus 1 volt. You can see that. I will increase it now to, let's say, the limit is 2.4 volt. This should be still working, and you already see here overload. On the positive side you see also that it is clipping. Okay, plus overload, that's okay, no problem. I will increase it even a little bit more. I go to 3 volt peak, and you see that the line here is flat, and that's okay. But in the previous model, in the 101, because of the lack of the plus or minus overload, you get always a positive overload, and you get a wrong graph. I try to blend. I will blend it in the video that what it was. So that's also fixed now. That's good. There is one thing which is a little bit weird, and that is, as you can maybe see, that during this transition, I'm now in the auto mode, so he should correct his scaling every time you see sometimes small sign of plus overload or minus overload. I don't know if, yeah, minus overload is also there. Even if I'm going to set it, let's say, in the 10 volt scale, so he's not clicking anymore, yeah, then it is working, but then of course we have no overload because we are in the scale of 10 volt, of course, yes. But if I go back to the auto, then of course he wants to go back to the millivolt scale, which is fine, but I'm wondering what is happening during that very small time of the overload. So I will do another measurement to see if there is something wrong with the impedance at that moment that it is switching. Yeah, so I will do another setup. So my new setup contains a resistor of 1 mega ohm here, which is in a serial with the digital multimeter, which has an impedance of 10 or 11 mega ohm, and here you have 1 mega ohm, and I'm measuring the voltage via the oscilloscope over that 1 mega ohm resistor. So what is happening at the moment, that you get, I don't know, the overload, the very small moment of overload. So I switch on this, and you can see already on the oscilloscope that there is an short duration of a higher voltage over the 1 mega ohm resistor. And that has to do with the auto scaling, because it has to scale from the millivolts to the 10 volt scale, and that will be so I made a setup now with the O1. You can see I have 10 volt, display is 9.5 because of the resistance of 1 meg. But the 1 meg is also connected to the oscilloscope. I was forgotten to calculate that is also 1 meg, so it is 500k, the resistance, which is in series with the multimeter. But what is happening if I switch the power off? You see here no volt, 0 volt. I put it in the millivolt scale because that is not completely automatic done in the O1. It is that they are saying auto range, but that is only in the millivolt or only in the volt range. But it will shift from millivolt to volt. Let's see what is happening at the moment I will press 10 volts on my power supply. You get here also and it takes a while before the 9.5 volt is displayed. So let's do it again. Switch it off. I set it again in the millivolt scale to get a good auto range. I switch on 10 volt. You see, and there it is. If I do again with the Rigol, same. You already saw the pulse. I was forgotten to switch it off. Okay. It is a remarkable smaller pulse in duration and in amplitude. So I think the Rigol is in that perspective better, and it is also much faster that it scales up. Of course, this is in the medium and that is in the low speed. So, but okay, the concept is that if you have an auto scale, then there is something happening which is measuring. So that should be normal, I guess. So, and even then, the current drawing is so low that you will not notice it, I think. So that concludes the video. I think it's fine that Rigol had take some action to get this problem out of the way, and so the auto scale function is working, and the overload is working. You get some extras, the plus and minus overload. I didn't check all the other software things yet. I don't know if that is really improved. I have seen that the software updates of Rigol are not that fast. I mean, the last one is I think from 1 year ago. So yeah, okay. But let's see. So see you next time, and thank you for watching. Bye bye.